Hello and welcome to my YouTube channel. So the last time we stopped at signed integer types. So today we'll look at unsigned integer types. But a part of the unsigned types is character types. That's not an integer type, but it's an unsigned. So we'll include that one as well. Okay. I think from the last time I say it's 2 to the bit size. That's the size. It should be 2 to the bit size minus 1, that's in the exponent, minus 1 as the top range for the positive range, and for the bottom half for the signed types you have negative 2 to the bit size minus 1. Okay, so just to clarify that sizing there. So but just remember, half is for negative and the other half is for positive numbers. Okay, so the unsigned type, here we have unsigned chars. Okay, this is an unsigned character type, so we could enter any ASCII value there. We could even use a colon for this unsigned character type, right? Once it's on the keyboard. Okay, the other one is unsigned short type. Okay, and this is integer type. Okay, unsigned short. Okay, I forgot my variable name here. So my first unsigned char. Okay. The other one is unsigned short. So you do my first unsigned short. Okay. And we set that within that short range. So let's do, I think short is usually 16 bits. So let's do 20. It doesn't matter. Okay. Next one, unless it's beyond range. I think it's 32,000 something for short. Okay. So let's do unsigned. Let me make this a little more clearer here. Okay, so that they're like the lines are corrected. Okay, so unsigned int type. So my first unsigned int. Let's make that 205. And then unsigned, we have unsigned long type. My first unsigned long. And then if we need more range, right, let's make this 12,000. If we need more range, we'll do unsigned long. Okay. And then we do my first unsigned long. Okay. And yeah, my variable names are very long, but yeah, you don't want to make these too long, but just for clarification purposes, that's fine. Okay. And there you go. So how do we print? We do standard out, cout, standard cout. We could print the value as well as the type ID beside it. Okay, so let's do, we already have the type info. Let me move my camera here. We already have the type info package here. So let's do, let's print out. Okay, so my first unsigned char, as well as the type ID, make a space there. And then we'll do the type ID, right? So type ID, my first unsigned char dot name. Okay, that's the dot name there. Okay, and then backslash n. Okay, and we need this 4 more times, right? So we could copy. So let's do shift down, control C, V. Okay, one more, V. Okay, so we copied this 4 times. Okay, so we printed the character and the name type ID, right? So let's update these ones. So instead of character here, let's do a control here. So instead of character here, we'll name this short. Okay, escape that. And then instead of character here, we'll name this one int. And then instead of character here again, we'll name this one long. Okay. And then instead of character here and here, we'll name this one long. Okay. So now we have all these variables. We've declared and initialized them, and we'll see the types as well as the type IDs. Okay, so this semicolon here, it's a character type. The type ID is H. The short is 20. Short type, unsigned short type. T 205 unsigned int J. That's the type ID. Unsigned long type ID M. Unsigned long type ID Y. Okay, so that's all the unsigned types. So with this unsigned type, which is the full range, and the signed type, which is the range split in half, one negative, one positive, we've declared all the major numeric types that are used in C++. So these are all the fundamental types used in C++. Okay. The other types we have is the floating point types. Okay, so how do we declare and initialize those? So let's comment out this one and look at the floating point types. Okay, so we have three main floating point types. Let's go here. We have float. So we could do float my first float here. Okay. And we need decimal. So just remember, these floating points is based on precision. So float has a lower precision than a double, than a long double. Okay. So precision is what makes these floating point different. So why do we need to have three different ones? Maybe given your problem, you need more precision in terms of decimal points than other problems. Okay, so it's always based on the data that you're trying to put inside the computer. So do my first double. Okay, let's do that. 1 1. Okay, let's make this one 1 2. Let's get some more here. 1 2 3, and then double my first long double. Okay, so this one is actually a long double. Okay, so again, more precision. Okay, so long double, we'll make this. Okay, all right, so let's print out the long double. So I'll copy, let's just copy the print statements here. So we need 3 print statements that we could use here. So copy here. Let's delete that one. And then on comment that one. And then set this one to first float. Okay. So this one is first float. The other one is first float again. The other one is first double. And this just saves some time, right? Copy in the code here, and so now it's first double. The last one here is long double. Alright, so instead of unsigned, we could take out the unsigned here and call this long double. Take out the unsigned here. escape this one. What's going on here? Oh, made a mistake here. Take out the onside here and do a long double. I hit the wrong key. It did a screen print. Okay, so now we have all our floating point types. So with these floating point types, signed types and the unsigned types, we've declared and initialized all the major numeric types in C++. Okay. So for floats, the type ID is F. For double, type ID is D. For long double, type ID is E. Why do we need a type ID? Maybe we can use it in some algorithm somewhere. Okay. The next type we have, which is non-numeric type, is our booleans. Okay, so these are switches on and off, right? So for boolean in C++, you do bool, and you could say my first bool 1. And we have these built-in keywords from our keywords cover, so true. And then bool, my first bool 2, set that equal to false, okay? And then we could print, right? So not system, standard, stuck on Java there, standard library, cout, and then my first capital F, my first bool, well, I made a capital B there, bool 1, we need some space here, then we need the type ID, right? Type ID, my first bool 1, dot name, okay? Let me just do that, make some space, okay? So that's these booleans here, okay? So that's my first bool 1, type ID there, and it will come after this this line, okay? Okay, so for my first bool 1, it prints integer value 1. So we could see here C++, with booleans, it returned a integer value. Okay, so let's try bool 2, okay, and see what happens. Returns a 0. So an integer value is returned when you declare booleans in C++. Okay. Oh, the other thing here with this first long double, if you notice, some precision is gone here. We'll look at how to format when we go over string formatting, formatting output in the next couple slides. Okay. So the last type we have here to cover before moving on to user-defined types is the void type. So you do void. So this type here is when there's no value, absence of value. Okay, so it's not 0, it's that the value is missing, right? So no value. So void, my first void. But we can't declare this in C++. We can't declare a variable, right? So we usually use these in functions, and we'll see how to use a void type function later on. Okay. Alright, so that covers all the fundamental types that we have here in C++. And we'll move on to these user-defined types. Right, so we have 3 main user-defined types: class, structs, and enums. And we'll cover those in our next video here. Okay, so just remember, these are the building blocks for your toolkit as a software engineer, right? So the data types are very important because we take the real world data and we have to mimic the same real world data in code. So we have to match like the data types. So for example, we have arrays, right? If it's a time-based array, we could represent that as a integer collection, right, of times. So that's why we need to understand these data types, right? So if it's dates, we could represent the months as integer collection of these different month dates and stuff. Okay, so just remember, it's mimicking real life data, whether it's time series data, categorical data, quantitative data. So we have to be able to understand these data types, that later on we could do our different algorithms and functions on these data types. Okay, so the next video, again, it'll be user defined types, and these are made up of the fundamental or the primitive types in C++. So that's why we cover all the primitive types first. Okay, thank you for watching. See you soon.